The columns are in, they look good. Now I've got to figure out how to actually put that gate together. And it's big, it's 15 feet long and about 7 feet wide, and I don't have a concrete floor, and my crane won't reach the fabrication table. And so what that means is I've got to build a temporary platform to keep the gate nice and flat as I put this thing together, so that when I stand it up, it's all in a plane, and the latch and the hinge and everything works the way that it needs to. Let's get to it. My idea is to put 3 pieces of a light I-beam that I have on hand across, with one end supported by my concrete floor over in this area, and the other end supported over here in the gravel. The ace in the hole is I have the footing for the crane over there, which will make a nice, spot that I can fasten the leg underneath the supporting I-beam. And right here, someplace, I have what I have used for an upsetting block, which is the counterweight off a forklift, about 800 pounds, under the grade. I don't know if you've seen it yet, and I think I can uncover it right here. That'll hold up the end of a table. I've got a 1, 2, 3, 4, 5. I got 5 bags of Sacrete premix that I've had out there for probably a year. A project that I thought I was going to get done, that I needed to get done, that I didn't get done. So this stuff has been stacked up in the dry under a roof for about a year. And I bet probably a third of it has drawn enough moisture just from the ambient humidity in the atmosphere to hydrate and get hard and get crunchy. But in this little footing, it just doesn't make any difference. All it really has to do is hold a base plate fairly level, get a hold of some anchor bolts that I've welded on there, hold it below grade so I can drop a vertical leg down there, put a few tacks on it, and put together this temporary platform. If it was anything other than this, I probably would throw this stuff away, or at least half of it. But let's see what it looks like when I break these bags open, break up some of the chunks, and see if it'll actually mix up. Just fine for what it is and who it's for. Just a piece of 1/2 inch by 5, I think, with a couple of 5/8 carriage bolts welded to it. Better than nothing, but as far as I know right now, this is a one-use application, so it's gonna be great. Right now, all I have to do is create a plane, hopefully level, that I can lay a gate out on, that's low enough that I can lift the gate with my crane, high enough that I can do a lot of welding without just crippling an old man's back, and not plug up my shop so thoroughly that I can't get around and use the other tools. I think this is the plan. Good. So I'm going to use as the benchmark the height of those 2 I-beams that are sitting on the concrete, because they are the same and they are higher than this one. And I can shim up right here, and then I'll measure up off of these other 3 bearing conditions to hopefully get a uniform level plane. So I'm capitalizing, or trying to capitalize, on this strip of concrete right along here as sort of an immovable base. But for some reason, and unbeknownst to me until yesterday, this end of this strip of concrete is 3/4 of an inch lower than it is down there by the drill press. I don't know how that happened. It was probably 9 years ago now. I set up an edge form, graded it, Dustin and I poured it, and I'm assuming that probably we just stepped on that form right there a couple too many times, you know, prepping the grade on the inside. Maybe I hit it with my tractor, I don't know. But it doesn't matter, because I'm shimming up with that piece of 3/4 inch square stock to where the top of these shoot, you know, with my laser within, I don't know, maybe a 1/16. I'll put a string line on it and see. But the critical juncture now is to forget about that, assume that that's good, use the elevation of the top of these I-beams as the new benchmark, and make sure that we are within tolerance with our 3 bearing locations. One over at the column, one on the piece that I poured yesterday, and one on this upsetting block, 800-pound chunk of steel bedded in concrete that I have right there, that I haven't used for anything for probably 7 years. So once that is all determined to be, you know, really close, I'll go ahead and tack this new location out on these 3 beams, and we're going to be getting close. So this is a piece about 1/8 of an inch thick. I think it's part of the jacket that I cut off of a piece of canister Damascus that I made for either A-Bomb or my son Adam. So anyway, we're going to repurpose this, see if it's about right. Just right. Illustrating once again that it's always better to, when you're creating a bearing condition or an elevation in a piece of work, when you're cutting the post or putting in the shims or setting the shim packs under the tilt panel or whatever it is, shoot a little short, because you can always lift it up and add a little more distance to get to where you want to be. But buddy, it's hard to cut off something that's fastened in place just the right amount to get a 0 net fit when you are creating a support that is a little subjective. Start short, shim to perfect. So now I'm going to square up these 2 I-beams, make sure they're the same length, and get them perfectly parallel with at least one end perfectly square, because I'm going to need that when I start laying out the gate.
Kurtis Eveland's painting, sandblasting and painting business is just up the street from me, and he's been handling the finish on my exterior steel fabrications and blacksmith project for years. Ever since, in fact, I finally realized that as good as powder coating is, it always gets dinged or chipped or scratched at installation time, and it can't be repaired like paint can. So between the fact that paint can be fixed and Kurtis is handy and very professional, he's always a solution when it comes to projects like this.
So Kurtis, how long ago did you get interested in sandblasting and painting automobiles and equipment and fabrications?
You know, that's a good question, because my dad was a painter, my grandfather was a painter, and his dad was a painter, so It's kind of a generational thing.
Yeah, you had no choice.
We never painted metal, so this was a new thing.
Yeah, it was hard for them maybe to understand your fixation on painting metal.
This is kind of an example of what we normally do through the shop. Sandblasting is something that we started out doing because we thought there was a need for old rusty steel and metal that needed to be cleaned up. So after we began sandblasting, we decided that there was a need for painting, coatings and protecting the steel after we've sandblasted, because a lot of the customers that we have were asking for that. We, just like this project here, we'll start with some rusty steel, and we'll prime and paint it to protect it. And some of our jobs are for protection, some of it's for beauty. We do kind of a large mix of multiple things. After the sandblasting, we always want to prime first. We started off using DTM products and found out that those don't work as well. So we like to always use an epoxy primer. That's kind of our first stop. That's where we always start. And after we epoxy prime, then we'll use just a variation of different coatings. This one's going to be a polyurethane because it holds up really well to the sunlight and UV rays. One of the advantages of paint over other coating systems is the repairability of it. It's very easy to repair. You can sand in town, in the field, retouched up. It does have a long life expectancy, and if you do it right, if the epoxy and the polyurethane are going on together, they usually take about 7 days of cure time total. They may dry a lot quicker than that, but it does take about 7 days to get a full cure out of the coating. The epoxy we're going to apply today is going to go on to about 2 to 2.5 mils dry film thickness, and the top coat is going to be about 3 mils total thickness after I get the 2 coats on. So the blasting provides an anchor tooth profile for the paint to stick to, the epoxy. It goes down into all those little tiny crevices that the sand makes, and it allows the paint to really lock on.
Actually a mechanical bond on
Correct.
the tooth.
Yeah.
Awesome.
The nuts on these 3/4 inch anchor bolts are set to height, precisely to height, so that the posts are plumb in both directions, and the weight of the post is bearing on all 6 points. I'm about to fill the space under the base plates with non-shrink grout to make sure that the load on the hinge post is uniformly supported and not just at the anchor bolts, and to fill the opening under the plate so that it looks finished and doesn't fill up with leaves and dirt and yellow jacket nests.
Unlike most cementitious products that shrink as they hydrate, that get smaller as the chemical reaction advances, non-shrink grout stays the same size. That's important when you want something to be held in exactly one position. So we've got some Quickcrete non-shrink grout. It's all that was available in Roseburg. I've never used it before. In fact, it's probably been 20 years since I've used any non-shrink grout. But whether it's Quickcrete or any other brand, you better follow those directions, the mixing instructions and the stand time and the cleanliness of the substrate. You better follow the directions if it's critical that the non-shrink grout, in fact, does not shrink. So the 2 pieces of information that are critical on the back of this bag for me today are that I want it to be a plastic mix. That is, I can move it around, but it's not going to run out. That means I add 1 gallon of water to the contents of this bag, and I have about 25 minutes of working time. My guess is, after 25 minutes, if you're doing a flowable mix or a fluid mix, you're just not going to get it to run in where you want it to go. And besides that, you probably shouldn't be disrupting that initial set. I mean, if this is going to attain its ultimate strength, which is up around 10,000 psi, and if you don't want it to be pulled away from the things that you're holding apart, you got to get your work done in a hurry. Let's see how we do. 1 gallon of water. The advantage to putting the water in first is you don't have big deposits of dry material at the bottom. You can't get mixed up.
Now, as much as I love forging steel, the work that I'm going to be starting in the next video is going to be almost entirely fabrication, which is just cutting and welding. It's a temptation to really jazz this project up because Cy Swan and I have done some pretty ornate gates in the past. They were smaller, nothing this size, but it would be fun to turn this into a blacksmithing legacy project. But I have other work and other projects to deliver for my family that I promised to them before this gate came up. And so, less is more. There will be blacksmithing. There's going to be some big rivets, and I'm going to be including a process called flame bending or heat shrinking. I sure hope it works. Thanks for watching Essential Craftsman, and keep up the good work.